All right, good morning, good afternoon, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, subscribe to the channel and leave a like for this lesson. Now, in today's lesson, we're looking at Kirchhoff's rules, and basically these rules help us to find current going through a particular resistor and calculate the power, especially for complicated circuits. All right, so but first of all, what you should understand are the rules themselves before we even go to problems. Okay, so suppose you have a circuit like that. So I'll move a circuit like that. Okay, and you have some resistors there. Okay, we'll start with a simple circuit like that. Okay, the first thing that you should identify is the positive part of the battery. So for instance here, the big side of the battery is the positive and the other part of the battery will be negative. This will be very important because it will enable us to know the direction of the voltage and whether the voltage is positive or negative. Then from there, the first part here of the resistor follows the sign of the battery is connected to. So here it's connected to the positive, so it will be positive here, and this side it will be negative, right? Then for this one, this part follows this part, so meaning that this part will be negative and this side it will be positive. Okay, so identifying the signs that should be allocated to each of the resistors is very important. Okay, suppose now there was another circuit here. Okay, and let's see. Let's say there is another circuit and it has a resistor there. Okay, there is another resistor there. Okay, so for instance, all right, so in this case, this part will be the opposite of this part. So this will be positive and that will be negative. This side will be positive and that will be negative. So that is basically how you can follow through with this. So this side is positive, this is negative. Then this part will be attracting this, so they have to have different polarities. So this will be positive and that negative, and so on and so forth. So this is how you identify. Now, the first thing that I want to talk about is loops. Okay, or rather the second thing. So a loop is basically a complete circuit like this where you are enclosed completely. So this is a loop. So this is loop 1. It is completely enclosed. This is another loop which is also completely enclosed, and we put an arrow showing the direction of the loop. So here the loop is in that direction, which is clockwise, and here the loop is clockwise. Okay, so it's important to identify the loops, as they will be also important in identifying whether we have a voltage increase or a voltage drop on a particular resistor. Okay, so for instance here we have a particular voltage here. Our loop is going clockwise. Okay, so we are moving from down, going down like that, and going down like that. Okay, so now if we move from negative here going to positive, if we move from negative going to positive, it means that we are increasing. So meaning that here this will be positive, so there is a positive voltage there. Okay, so that is voltage 1 here will be positive. Here, when we move from positive to negative, meaning that the voltage here is dropping. So moving from positive number to a negative number, which is smaller, means that there is a decrease there. So meaning that the voltage that will go through this resistor will be negative. So that will be negative. Okay. When it comes to this resistor here, again, from positive to negative, meaning that there will be a drop. We're going from a big number to a small number, so there will be a drop. And the voltage, which is V3, will also be negative. Okay, so these are the things that you should understand. So coming to the other loop here, same thing. When we start, so we should notice that we should complete the entire loop. So we start here, we go there, and that is our starting point. So that is where we end. So here, same applies for this loop. From here, positive to negative, what is happening? A big number to a small number, that is a drop. So meaning that this voltage here, which is voltage 4, just for numbering, so voltage 4 here, from positive to negative, it is a drop. So this will be negative voltage 4. Okay. Then here, from positive to negative, we are going in this direction. So positive, negative, that is a drop. So that will be whatever voltage here, voltage 5, that will also be negative voltage 5. Okay. These are things that are important to know, as they will help you in solving questions. Okay. And what you should know is that summing all the voltage in a particular, summing the voltage in a particular loop is equal to 0. So summing all these voltage here, that is positive V1 minus V2 minus V3, should give us 0. So this is the first rule of Kirchhoff's. Okay, so this is rule 1. Summing all the voltages in a particular loop, that should give you 0. So same applies here. If we sum in this loop, there are only 2 volts, so that is 2 voltages, that is negative V4 plus V5. This should also give you 0. So this is the first rule, which is known as the voltage rule. Okay, then now we come to current. Okay, current always moves from the positive side of the battery. Okay, so current will always move in that direction. Now, if this is current 1, if current reaches a particular junction, okay, if it reaches a particular junction, a junction is a point where 3 points are meeting. So we have 1, 2, 3. So if current reaches a particular junction, it splits. So there will be some current going in that direction, which we're going to call current 2, and some current which will go down here, which is current 3. And basically we can say current 1, which is this one, is basically equal to current 2 plus current 3. Okay, so now this current 3, okay, let me just, this current 3 or this current 2 will run all the way through this resistor until it reaches this junction again. So this is a junction, so this is current 3, and this current 3, or this is this is current 2. So this is current 2 will run through all the way until it reaches the junction here where it will pause. So this is current 2, and current 3 will run all the way from this point until it reaches this junction. And when it pauses, these two currents will rejoin and they will form current 1 again. So they will form current 1 again until they reach the battery here, so which is current 1 here. So this is known as the current rule, the second rule of Kirchhoff's. Okay, so that is current entering a junction, as you saw current 1, entering this junction is equals to the current leaving the junction. So this current is leaving and this is leaving. Okay, same applies to this current, which is current 3, and current 2 entering will be equals to current leaving. So current, which will just be the same equation, which is current 2 plus current 3 equals to current 1. Okay, so these are two rules of Kirchhoff's. So if you've noted, we've talked about, first of all, assigning the positives and the negative. We need to start with the battery. So the battery will have a positive part and a negative part. The long side is the positive part. And the first side of the resistor will be positive and the other part will be negative. Then resistors facing each other will have opposite signs. So if this is positive, this will be negative. If this is positive, meaning that the other part will be negative. And if this is negative, this will also be positive. This will be positive. Then the other part will be negative, and so on and so forth. Okay. Now, let's look at an example and see how we can apply Kirchhoff's rule. All right. So we have a question here. Find current going through resistors 1, 2, 3. So this is resistor 1, resistor 2, and resistor 3. So we have our 7-volt battery here. So now we need to identify the charges. So this long side will be the positive, and this other part will be the negative. Okay, so this positive will run all the way up to here. So this is positive, and this will be negative. So this will counter. So this will be positive and negative. They will be opposite. And this will be positive, which is opposite to this one, and negative, like that. Okay. So now, after we have identified the polarities, we now need to identify the direction of the current. So current always moves from the positive part. So current will move from the positive part here until it reaches a junction. If there is no junction, it continues moving. So like here, this current, which we're calling current 1, has moved until that junction. And at that junction, it will split into two parts. So there will be this part which will go this direction. There is no junction here, so it will go all the way until it reaches that junction. We're going to call this current 2. Okay. Then there is also this current that comes from here, which will go until, let me just draw, to be here until it reaches this junction. So we are calling this current 3. Okay, so as current moves from positive, it will keep moving until it meets a junction. If it meets a junction, it will split into the directions of the junction. So the other one will go this direction and the other one will go into that direction. So we can see that current 1 is equal to current 2 plus current 3. So this will be our first equation. Okay. Now we have identified our currents, because here again, when these two meet at this junction, current 3 and current 2 will combine to form current 1 again, which goes there. So they come back again to form current 1. So if you were to take the other route, it would be current 2 plus current 3, which is this part, is equals to current 1. So it should be current 1. Okay, so current 2 and current 3 will rejoin here and they'll form again current 1. Okay, so that will be our first equation. Then our second equation will be considering the number of loops that we have. So the first loop that we have is this one. A loop is basically just a point that is enclosed. So this part is enclosed and this other part is enclosed. So we put a direction like that. Okay, we put a direction like that. Then now we'll consider the voltages at each of these resistor. Okay, and yeah, so we'll start with here. So voltage 1, we'll call this voltage 1. Okay, we'll say this is voltage 1 at this point. At this point, there will be voltage 2. At this point, there will be voltage 3. And at this point, there will be voltage 4. Okay, so now at this point, voltage 1, we need to check, is the voltage going to be positive or negative? So considering our loop direction, we are moving in this direction. So if we move from down here going up, we are moving from negative to positive, small numbers to big numbers, meaning that from small numbers to big numbers, it will be positive. So voltage 1 will be positive. Okay, so we say positive voltage 1. Okay, then again here, we are moving in this direction. So from positive, which is a big number, to a small number, that is a decrease in voltage. Okay, so there will be a decrease in voltage here, meaning that this voltage will be negative. So voltage 2 will be negative. We go here. Okay, here again, we're moving from positive to negative, meaning that voltage 3 will drop, meaning that it will also be negative. Voltage 3 negative. We don't have any other resistor in this loop, so we complete it by saying this is equal to 0. Okay, that is equal to 0. So that is the first loop. Then we go to the second loop again. We say we can start from any point. So we are moving in this direction. So moving down here from positive to negative, that is a decrease. Big number to small number, that would be a decrease. So voltage 4 here will be negative. So negative voltage 4. Okay, then we go here, there is the second voltage. So we're moving from negative to positive, meaning that voltage 3 will be positive. So from small number to big number, so that will be positive voltage 3. And we're done with all the resistors in this loop. So this will be equal to 0. Okay, now what we're going to do is this. Okay, we know by Ohm's law, by Ohm's law, voltage is equals to current times resistance. Okay, so by Ohm's law, voltage is equals to current times resistance. Now we're going to rewrite each of these equations. So first of all, we'll start with this one, which is just basically I1 equals to I2 plus I3. Then now when we come to this, we want to replace in this formula. Okay, so for voltage 1, the current that is going through voltage 1, we are using this formula, voltage is equals to current times resistance. So the voltage that is the current going through voltage 2. Okay, voltage 1, there is no current going through it. So, but we know what voltage 1 is. Voltage 1 is this, which is just 7 volts. Okay, 7 volts, that is our voltage 1. So voltage 1 is 7 volts. But for voltage 2, the current that is going through is I1. So that will be, there is a negative here. So that will be negative I1 going through voltage 2. So I1 is going through voltage 2. And the resistance there is 2. So times the resistance, which is 2. Okay. So that is voltage 1. Okay. Then that is voltage 2, sorry. Then for voltage 3, which is this one here, the current that will be going there is I3. So I3 is going through voltage 3. Okay, so it will be, there is a negative here again, so it will be negative I3, which is current, and times the resistance. The resistance here is 3, so it will be times 3. And we are done with this one. This is equal to 0. Okay, so that will be 0. Then now we come to the last one here. Okay, so on voltage 4, what is there on voltage 4? Voltage 4 is this one here. So the current going through voltage 4 is current 2. So that will be current 2. Current 2 times the resistance there, that is 5. And this has a negative, so we put a negative outside here, plus voltage 3. Voltage 3 is this one here. So voltage 3, there is a plus there. So the current going through voltage 3 is I3. So that will be I3 times the resistance here is 3. Okay, it goes to 0. Okay, then now here, that is the big part. So here for these voltages, you just use Ohm's law. So for voltage 1 here, we had the voltage, so there is no need for Ohm's law here. So for voltage 1, we had 7. So 7 times, okay, for voltage 1, we had 7, so we just put 7 volts. Okay, then for voltage 2, we don't have voltage there, but we know that the current going through there is current 1. Okay, so current 1, so I'm supposed to put current 1 here, sorry. It's good to check through your work so that you avoid mistakes. Okay, so that you avoid mistakes. So for voltage 1, we have 7 volts, which is this one. Okay, for voltage 2, we don't have voltage there. Okay, but we know the current going through there is current 1. So it will be current 1 times the resistance. We're using this formula. So times the resistance, which is 2. We go to voltage 3, that is negative, which is this negative. We analyze voltage 3. Voltage 3 is this one. The current going there is I3. So we'll say I3 times the resistance, which is 3, and this will be 0. Okay. We go to voltage 4, which is this one. So we say negative. Voltage 4 is this one. The current going through voltage 4 is I2. Okay, I2 times 5, which will give us this. Then we have a plus here, so plus. Voltage 3, which is this one. The current going through voltage 3 is I3. So we say I3 times the resistance, which is 3, and we say equal to 0 because we are done with the loop. Okay, now here it's just let's simplify the equations so that so for the first one we have I1 is equals to I2 plus I3. Then here we'll say 7. We can take this, we can take 7 on the other side so that it becomes positive. So we'll say positive 7 here. Then this will be positive as well, or would it be negative? Oh yeah, it will be positive. So when 7 goes there, it will be negative. Or if these go the other side of the equation, they will be positive. So it will be 2I1 plus 3I3 is equals to 7. Okay, then for this part, we have negative 5I2, which is this part, plus 3I3 equal to 0. Now, what we just have to do here is solve these equations simultaneously. We can even start with this part. We make I2 subject of a formula here. You see that I2, when made subject of a formula, will be equals to 3 over 5 I3. Okay, so just take your time here. When this goes there, it will be negative divided by I5. So it will be this. Okay, so now we have made I3 subject here, which gives us this. Then now here, we can choose to replace I2 here. Okay, or what we can do is we can, if we replace I2 in equation 1, okay, so this is just simultaneous equations. For those that are even doing what, this linear algebra, you can easily make this into a matrix. Okay, let's try solving it into a matrix for those that are doing linear algebra. So first of all, we need to put this as I1 minus I2 minus I3 for the first one. Okay, we'll solve it by substitution as well. So this is equal to 0. So let's say I2, well, let me just do substitution here. But you can use linear algebra by methods of matrices to solve this. So, but you have your I2, which is equals to this. When you replace it here, it will be I1 minus our I2, which is 3/5 I3 minus I3 equal to 0. So we've replaced this equation into this one. Okay, then we have this one. Then now we can solve these two equations simultaneously with this one. Okay, so we have okay, let me simplify this one. Which will be I1, then these will simplify as -8 over 5 I3 equals to 0. Then here we can say, in fact, we can even make I1 subject of a formula here, so that we have I1 equal to 8 over 5 I3. Okay, and what we can do is we can replace in this equation here, which is our equation 2, so that we have 2 times our I1, which is 8 over 5. Let me write it in white. 8 over 5 I3. Okay, then here we have 3 plus 3I3 equals to 7. Okay, so let's simplify that. So we're going to have 16 over 5 I3 plus 3I3 is equals to 7. Here we make 5 subject of a formula, so we have over 1 there. So this will give us 16 plus 15. When we do everything there, it will be over 5. 5 there, 1 plus that will be 16. 1 there, 5 plus that will be 15. So this will give us 31 I3 equals to 7. So here, just simplification. Okay, then here we can finally say I3 is equals to cross multiplication here. So 5 times 7. So 5 times 7, that will give us 35. So it will be 35 over 31. Okay, 31, which will give us about 1.1. So that will be our I3. Now we can use this equation to find our I1. So we say I1 is equal to 8 over 5, I3, which is 35 over 31. Okay, so now here we're going to just simplify. So that is okay, so 35 divided by 5, so that would be 7. 7 times 8, 56. So this would be 56 over 31. Okay, Okay, so that will be our I2. Then now our I3, we can use, we need to find our I, so this is our I1. We need to find our I2 using this one. So we have I2, let me just put it here. I2 will be equals to 3 over 5 I3. Our I3 is 35 over 31. So that is 35 over 31. Okay. Then we can simplify this as 7 times 3, which is 21 over 31. Okay, so these will be the currents. And we are done. So basically, the idea is here. After you make the equations, these equations, then for the voltage part, you consider the voltages on each. So the voltage here was 7, and so on and so forth. Then here, this is where you also need to pay attention. Okay, but once you make these equations, you are good, you are all and good, because from here it's just a matter of using some algebra to find the values of I1, I2, I3, and so on and so forth. So the number of unknowns dictates the number of equations that we have. So here we have I1, I2, I3, and we have 3 equations. So this one will work out perfectly. So you should check that, make sure that the number of unknowns is equal to the number of equations. Okay, so let me just put up a question here. So these are the currents going through resistor 1, resistor 2, and resistor 3. Let me just put up a question for you to try out. All right, so just these 3 questions. Find the current through the following resistors. So for here, you do what we were doing. Question 2, we have 12 volts, 3 ohms, 3 ohms, 6 ohms, 7, 2, 1, 10 volts, and 3 ohms. Right, so I'll be waiting for your feedback. Otherwise, it's a good evening. Have a great day. So I'll be waiting on you.